I think we're going to start with the presentation now. We're going to be talking about depreciated cost analysis. There's my email if you want to get a hold of me. I like to respond with email. Depreciated cost analysis is based in the appraiser's responsibility, called out on USPAP, that we are to be able to, we need to use recognized methods to support our adjustments. So it says our responsibility is to be aware of the recognized methods and then to be competent with the recognized methods. So for many, many years, thousands of appraisals, I never heard about depreciated costs, so I was not aware of it nor competent. But when I found it and started reading about it and thinking about it, it made a lot of sense to me, and I'm hoping to share that to you with you this morning. Any system that we use, whether it's paired sales, group data, cost data, we have to use the data credibly in order to do a credible report. So we're going to talk a little bit about the credible use of data because it says again in USPAP a little bit farther down on line 433 to 438 that appraiser must be aware of, understand, and correctly employ those recognized methods and techniques that are necessary to produce a credible appraisal. And that data is a big part of that right here. Diligence is required to identify and analyze factors, conditions, and data. So if there are no paired sales, that's a data limitation. And if we're doing group data, and you probably have seen what happens when you're not careful about what goes into the group and what inferences you can draw from that. But we're going to talk a little bit about data and how to tell if you have the right sample size or the right number of observations to do a credible job. So again, the recognized methods have differing data requirements. We need to match the method to the available data. So we start with the data and we go back to see which method is most appropriate. And when we talk about data, I'm mostly talking about MLS data, okay? And when we have MLS data, we're concerned about two parts or two aspects of the data: the sample size, that's the number of observations, and then the sample fit. That's just a term that I use for how well the data fits the subject. Like if you've got a house that you're appraising that's high end and you've only got data for the low end of that market, you have to kind of question if the data fits well. So there's a really good book out there called Introduction to Statistics for Appraisers. It's hundreds of pages long. I didn't read the whole thing, but I found this little tidbit about sample size. And I asked several teachers through the years, USPAP teachers, or CE teachers, what is the sample size that we need to be credible? Because I did remember from going to school in psychology classes and so on, they always talked about sample size being a very important part. So it boils down to this. This N here, that means the number of observations. It should be greater than or equal to 30 for real property valuation work. And now this book was written by Marvin Wolverton, who knows all about appraisal and he knows all about statistics. So just remember that number 30. And there are some ways to reduce the number. For instance, you've all heard of the bell curve. Down here, the bell curve. This is a bell curve when it's shaped symmetrically. Okay, it's called a normal curve. We don't need to see the curve in order to know if it's normal. All we need to do is look at the mean, the median, and the mode, see how they're all lined up at the same point. And this might vary a little bit, but if you have a mean and a median that are really similar, you don't need 30 in the sample, you only need 15. So when they're equal, you need 15. When they're spread apart, you need 30. And this is what Wolverton is saying. This is the typical curve you would see with real estate, right? Here's the mean. And there's a saying about the mean chasing the tail, okay? What if we have 2 or 3 sales out here that are like, $1 million, and then we have 2 or 3 sales over here that are $200,000? Well, of course, the average is going to be farther along toward the high end. The middle value is probably more credible to use in that case. But the most frequent number might be, that's most of the houses in this neighborhood sell for this number. So when those are spread out, which is almost always the case in real estate, then we need 30 for credible use of data, for instance, on things like paired data, excuse me, on group data. Paired data, you only need 2, I'm sorry. So sample fit, that's just again, a non-technical term I use to refer to how well a group of houses match the subject. And that will change with time, but remember that there's more to it than just how big the sample is or the number of observations are. It also has to do with how well they match. Now, USPAP doesn't tell us what the recognized methods are. That comes from a book, or one place it comes from is this, The Appraisal of Real Estate 14th edition. And I quote from this throughout this presentation, and I'll show you how to find those quotations on my website so that you can be prepared. But our source for recognized methods is this publication from the Appraisal of Real Estate, or called the Appraisal of Real Estate. It's already 14th edition, so it's been around. And this edition was a huge update over the 13th, because this one was published after the crash, and it tried to expand on the things that we need to know post-crash in how we use techniques and data, okay? Now, the recognized methods that they cite are paired data, which is the technical term for match pairs or paired sales. I was hoping that would mean paired cost data. It doesn't, but we'll get into that. Group data, that is when you look at 2 groups of houses. I use this on every report. For instance, if I have 40 sales in my neighborhood from this year and 40 sales or so from the same neighborhood last year with the same search criteria, then I have a basis for making a time adjustment to see if if the market went up or down, the median value in those two groups. Okay. Secondary data. The reason that they call this secondary is because it does not come from the comp pool in the report you're working on. It doesn't come from the current data in your specific neighborhood. This is more like assessor data. It could be data collected by a data research firm. It could be a survey that's applied to other situations, as a percentage. And we'll talk about that, because we have got a resource for you to use secondary data, which again, it's a recognized method. It has to be applied properly. Statistical analysis, this is where we get into regression. And I'll show you a little bit how we use regression within the cost data. But that's the umbrella under which you would find regression. Cost-related adjustments, that's what we're going to be specializing today. That's using cost data to compare properties. And then this one, capitalization of income differences, that's not used very often in single family if there's no income. So we're just gonna state that it's there, but it doesn't apply. This is for every property everywhere, right? So we're only talking about houses today that are probably not rental properties. So the logic of the 1004, the 2055, the G part, the multifamily, all of these have the same logic as far as how we handle depreciation. So we're talking about depreciated cost. First, we're going to talk about the depreciation half of that. When you enter effective age on page 1, right over here, effective age, it results in a depreciation calculation on page 3. Okay, so now this might be already in your settings on your software, 60-year lifespan. You can change that in your software. But this 15 came from page 1. It was your estimate of effective age. 15 divided by 60 is 25%. So we've got 25% physical depreciation, okay? And we'll talk about functional and external later. So this 25% represents roughly $50,000 in this grid where I got the screenshot. So that kind of makes the inference that, hey, this must have been a $200,000 cost, right? And if you thought that, you were right. Here's our site value, the cost of the dwelling, the cost of the garage, about $200,000. The depreciation is 49. So this has got 15 years effective age and a 60-year economic life. Indicated value by cost approach is 243. And of course, we know this is only as good as our estimate of depreciation. So in my brain, I think it's better to, if we can estimate a market value, we can get back to the depreciation. So that's something that we may talk about later. Now, economic age life depreciation, that's the technical term for what we most often hear as age life depreciation. And the reason I want to make a point out of that is because we're talking about economic effects, not just something wearing out. We're talking about it adding value to the land. We're appraisers. It all starts with the land, right? So the logic of the 1004, et cetera, is economic life. There's only these few variables: economic life, effective age, and remaining economic life. And you've probably already done the math here, but we'll review it after we get some definitions out of the way. Economic life is the period over which improvements to real estate contribute to property value. And that's from the Dictionary of Real Estate Appraisal, 6th edition. Don't need a page number because you just look it up by the letter E. Okay. Effective age is the age of property that is based on the amount of observed deterioration and obsolescence it has observed now or sustained. Now notice it's deterioration, that's physical, but it's also includes obsolescence. That could be external or functional, right? It could have brand new green carpet, which has no value in the market. It's not worn out carpet, but it's green carpet. So it doesn't have value maybe in a certain market. Remaining economic life, this is the estimated period over which existing improvements are expected to contribute economically to a property. Again, it's economically. You could have a house that's in great shape, that's got 2 bedrooms and 1 bath, and people come along and buy those, and in one of my neighborhoods, tear them down and build a 6-bedroom mansion because the land is so valuable due to proximity, school district, and so on. So it's the economic impact of that improvement, not the physical condition. Physical has something to do with it, obviously, but the economics are what we are paid to understand, analyze, and report. Going on with remaining economic life, it's the estimate of the number of years that the structure or components, that's important. We can break it down from the whole structure down to the components, have as the effective date of the appraisal. So on a 60-year-old house, the deck might only have, or excuse me, on a 1-year-old house, the deck might only have 20 years of life left in it, but the house as a whole has 60, and it'll last much longer than that if it's maintained, because of course we routinely appraise properties that are 80, 100 years old. Don't be afraid, this is simple algebra. In fact, I talked to my daughter and asked her where she first learned y equals ax plus b, and it was about 6th grade now, so it's middle school math. We don't even need to get into that, but economic life minus effective age is remaining economic life. That's a simple one that we all know. That's calculated for you in the form software. If economic life is 60 years and effective age is 15 years, what is the remaining economic life? And the survey says 45 years, right? If effective age divided by economic life equals the percentage of depreciation, we saw that on that example. 15 years divided by 60 was 25%, right? So if effective age is 15 and economic life is 60, what is the percentage of depreciation? Again, 15 divided by 60, 25%. Remaining economic life divided by economic life, this is getting a little bit deeper, more interesting. That's the percentage of cost paid by the market, which is a good percentage to know because we can figure out where the cost is based on unbiased third-party cost data. And if we happen to know what the percentage of depreciation is recognized by the market, we're starting to get close to our goal of making adjustments with depreciated cost. So, and here's another example. If economic life is 60 years and remaining economic life is 45 years, what is the percentage of cost paid by the market? Whoop, it's 75%, right? It's 45 divided by 60, 75. It's the same as 100 minus 25, the effective age. So the market's paying 75% in this case. So I just want to go through the definition from the Dictionary of Real Estate Appraisal. Economic age life method is a method of estimating depreciation in which the ratio between the effective age and the total economic life is applied to the current cost, not the reproduction value or the historical cost of the improvements, to obtain a lump sum deduction, also known as the age life method. So there's that reference from economic age life to age life. Continuing, in appraisal, a loss in property value from any cause, it's the difference between the cost of an improvement on the effective date and the market value of the improvement on the same date. Now, depreciation is used differently in different professions. Like in accounting, depreciation is kind of a concept. It's something in the statutes that say how fast you can depreciate something. People talk about their car's depreciation. You know, they paid $30,000 and now it's worth 15, so it depreciated 50%. In real estate, we're talking about the replacement cost, not the original cost. So the key concepts again in economic age life depreciation: total economic life, effective age, remaining economic life. And this is a key part of understanding this, that when we apply the concepts of economic life, effective age, and remaining life expectancy, the appraiser considers all elements of depreciation. You know, that's where we get into that obsolescence again. Functional, physical, and external are all rolled into one number. So the effective age estimate, and that's a key word, estimate, if we're going to do a depreciated cost on, for instance, a drive-by or a desktop, so we can estimate effective age. The estimate of effective age includes not only physical wear and tear, but also any loss in value for functional or external considerations. And that's on page 599. And I'll show you where you can keep that reference from the Appraisal of Real Estate. Okay, so now we've talked quickly about depreciation. The second part is cost. Here's a screenshot of the 2020 National Building Cost Manual. And we have a license agreement with Ben Moselle at this company to use his cost data in our software. So I'll be using this as a reference. Here's the cost data publishes average cost. Everybody has seen this. This is the high quality house, the low quality house at 1,000 square feet. This one costs $472,000. This one costs $87,000 to build the GLA part of it. Here's the Q4 is right around in here somewhere. But notice how the cost per foot goes down as the quantity goes up. See how that works? 122, 118, 115, 113, 111. So the average cost is not a good basis to use for depreciated cost. You'll get a smaller and smaller adjustment the larger the house is, which is going the wrong direction. So that's the first clue. Now let's just look at how to handle that problem. We're going to look at total cost rather than average cost. So to get total cost, you multiply the size by the value in the cost table. So 1,600 feet times 119.77 has one cost, and 1,800 feet times 116.57 has another cost. Okay, so the total cost of this larger house at a lower price per foot is $209,826. The smaller house at 119.77 has a total cost of $192. Notice we don't have to include the basement, the garage, the fireplace, the deck, anything else. We're only talking about the GLA here. So we can see that there's a difference in total cost between the smaller house and the larger house. So this is where marginal cost comes in. This is a financial accounting term. It applies very well to depreciated cost in my brain. It's the change in total cost divided by the change in quantity. And that's very, very similar to paired sales, right? The change in total price divided by the change in whatever it is, garage stalls, GLA. So we're going to see how to start with better data and work to some pretty good answers. So here is that prior information in a table. Notice that we had 1,800 square feet of GLA. The smaller house had 16, so there's a change of 200 feet. The average cost is 117. Here it's 120. The total cost is 210. Now it's 192. So roughly the difference is $18,000 in cost for a change in 200 square feet. So the marginal cost, and this happens to be a Q4 from 2020, the base cost, I round it to 90. But that's the cost of one more foot of GLA in a Q4 without regard to where it's located, okay? $90, key number. Marginal cost is the cost of one more. It's the ideal basis for depreciated cost adjustments because we adjust for one more square foot, one more bathroom, one more garage stall, and so on. Here's the example for a garage stall. If you look in the cost manual, 2-stall garage, 440 feet, $47.50 per foot, so it's $21,000 to build that 2-stall garage. The 1-stall garage costs more than half as much, right? 220 feet, it's half the size. It's got a higher cost per foot, and it totals out to $13,300 here. So the additional stall isn't $10,000. It's not half of that. It's a smaller amount. It's $7,500, $7,600. And if you've been around construction, you can understand why that's true. It doesn't cost as much to make it bigger as it does to make another one. Okay. The example of a bath. Now this is a little bit different than GLA or the garage. According to the cost manual, and that's what we want to use as a standard, right? It's a third-party unbiased source. We want to be able to point to that when we're questioned. According to the cost manual, and these are not exact numbers, but 2 baths are 20,000. And if you look at the cost of 1 bath, it's 10. So the additional bath is 10. In this case, average cost and marginal cost are the same, but that's just for bathrooms, and that's ignoring some of the complications. I'm sure if you've got a background in plumbing or construction, you'll understand. And that's why I want to introduce this idea of a streamlined cost approach. We're not using the cost approach to bid on a job. So within one quality rating even, okay, if you're just talking about Q4 houses, attached garages are going to cost less than a detached garage, right? There's a common wall here. But a lot of people would think that the attached garage might be worth more money. So because we're only counting garage stalls, we're just going to ignore that difference and treat them the same. I shouldn't say ignore. We're going to keep that in mind and realize that it's not critical to the mission here. A large 2-stall garage will cost less than a small 2-stall garage, but the way that shows up in the MLS data is it's a 2-stall versus a 1-stall, right? So that's all the detail we're going to expend our time on. And then getting back to the bathrooms, a 4-fixture bath, meaning it has a tub and a shower, toilet and sink, they cost more than a 3-fixture bath. But they're treated in my MLS or in an appraisal as 1 bath, right? It meets all the needs that a person has for hygiene. Now 2 baths sharing the same rough plumbing, in other words, one above the other or one back to back with the other, they will cost less than 2 baths with separate plumbing, right? You'll always, in a lower cost house with 2 bathrooms, they'll usually be sharing the same rough plumbing. And if you get into complex floor plans, higher quality houses, they might have separate plumbing just to make sure that the floor plan works the way the owner wanted it. So the streamlined cost approach again, the goal is adjustment rates. It's not bidding on a construction project. We assume typical characteristics. And I guess the reason is because even the comps within the grid are going to have different sizes, garages, different fixtures per bath. There's differences within the grid, and I guess that's why we need at least 3 comps, because there's differences, okay? They're not all model matches. This gets into a fallacy of logic. This is an excellent book. It's written by a guy, Dr. Bo Bennett. He's got a website and you can get email feeds from him and so on. But he calls it the ultimate collection of over 300 logical fallacies. And he names this one fake precision. And this is kind of the dry technical explanation, using implausibly precise statistics to give the appearance of truth and certainty. and using a negligible difference in data to draw incorrect inferences. And that's what we're doing all day long, is drawing inferences from data, right? And if we don't stop and think and use our common sense, we can write some pretty crazy things. It's kind of dry when it's written like this, but the beauty of this book is that he gives really good examples that just stick in your brain, and you can say, okay, I know what that one is. That's the logical fallacy of fake precision. So this is the story of a tour guide, and I think he's a retired appraiser. He's giving a tour in a museum, and it's they're in the fossil part of the museum right now. They're talking about you know, the origins of the world and so on. And he says, this fossil is 120 million and 3 years old. Well, the guest, who's probably a retired underwriter maybe, who knows, but they say, how do you know that, right? What's your support for that 120 million in 3 years? And the tour guide says, because when I started working here 3 years ago, the experts did some radiometric dating and told me that it was 120 million years old. Okay, so remember that when we try to make a mountain out of a molehill of data. And when it comes to the cost approach, we're just supporting adjustments. We're not proving anything. We're recognizing that there's different costs of the same thing as far as we can tell, you know, from an exterior. Excuse me. Well, now what I want to do is I want to combine the concepts of depreciation with marginal cost. I call it virtual match pairs. It's applying economic age life depreciation to marginal cost. And it uses the same logic as paired sales, paired data, the technical term. But here's the logic of paired data, and this is from the appraisal of real estate. Paired data analysis is used, or is based on the premise that when two properties are equivalent in all respects but one, the value of the single difference can be measured by the difference in price between the two properties. And that's right on page 398. If you've been appraising for a while, you see how hard that is to apply in the real world. So here's a paired data example of two sales that differ only in GLA, okay? Comp 1, 1,800 feet, sold for $250. Comp 2, 1,600 feet, sold for $236. And I'm going to use my discretion to give you goofy numbers because it makes the examples come out, okay? So the change in size is 200 square feet. The change in market value is 13,646. So the GLA adjustment is 13,646 divided by 200. So it's $68.23. We'll use 68, okay? So what happens if there are no sales that differ only in GLA? We can use the cost data. We can extract marginal cost. We can apply age life depreciation, and the percent of marginal cost paid is the adjustment. Here's an example. Here's the 1,800 square foot house. The cost manual says it's $116.57 per foot. The total cost is $210. We saw that already. The market's paying 75% of cost. How do we know that? Because effective age is 15 years, okay? So the market's paying $157.4 for the larger house, and they're paying $143.7 for the smaller house. You know, 16 times 120, 75% of that, so 144. So the change of 200 feet has a change in depreciated cost, I guess. Depreciated marginal, it's $13,700. It's that same $68 number. All right. Now, what I want to do is restate the quote about paired data. Here it is. Paired data is based on the premise that when two properties are equivalent in all respects but one, the value of the single difference can be measured by the difference in price between the two properties. My way of thinking about it, and I hope it's yours too, is that depreciated cost analysis is based on the premise that when two properties are equivalent in all respects but one, the value of the single difference can be measured by the difference in depreciated cost between the two properties. So if we know depreciation, we've got a really sound basis for making some comparisons, okay? The trick is knowing the depreciation. The trick over here is having good data. So here we start with pristine data from the cost manual, and we make some assumptions about depreciation that can't be measured sometimes, maybe it can. Over here we start with MLS, which can be kind of messy sometimes because it's entered by several different people. And a lot of times people or agents think that the MLS was designed to sell houses, not to report appraisal data. So here's something that appraisers learn on day one. Cost does not equal value, but I'm here to say that if you know depreciation, depreciated cost does equal the value, okay? So here's our example. Let's say a house sells for $200,000. The assessor, excuse me, the buyer and the seller, the agent, the county recorder, everybody agrees that the market value is 200. As an appraiser, we are trained to appraise, and we're only licensed to appraise things that have land attached to it, right? So let's say that we know that that land is worth $50,000. What that means is that the building is adding $150,000 to the market value, right? The market value of the building is $150,000. Now, the appraiser who bothers to do the cost approach can find some interesting data. She may find that that particular house has a replacement cost of $200,000. So, interesting. The market's paying $200,000, right? It costs $250,000, including the land. Everything above $200,000 is the depreciation, right? $50,000 of depreciation in this case. The building is, the value of the building is $150,000 and the value of the land is $50,000. Now, $200,000 is just a coincidence that that the market value is the same as the cost. Let's watch what happens when the land goes up to $60,000. So now the market's only paying $140,000 for the building. The cost is still $200,000. So there's got to be more depreciation, right? So there's this trade-off between site value and depreciation that's really important to keep in mind. If the total cost, within a total value, I should say, the higher the land is, the less value the building has. And then of course the opposite is true. The lower the land value, the higher percentage of it is the building. Now that artwork right there, this I didn't come up with that by myself. That I'm going to have to cite my source. This is Piet Mondrian. He was an artist that you probably recognize his work just from the look of it. But he was a very fundamentally important architect at the beginning of the 20th century. He is the beginning of modernism. And here's an example of modernist architecture. This is called The Glass House by Philip Johnson. I just love this. I remember I took architecture classes and we saw this, you know, back in the 1970s, and it still looks fresh and current. I don't know if I'd want to live there, but it'd be a great place for a B&B, I guess, nowadays. Another one, this is The Stahl House by Pierre Koenig. And this photo kind of made it famous. This is, you know, Los Angeles, and here's the Beverly Hills. But you can see that Mondrian's influence, that cubism. And then finally, this one's The Ames House by Charles and Ray Ames. You might be familiar with their famous chair, the Ames chair. It's a married couple. Ray is the woman, Charles and Ray Ames. But enough self-indulgence, time to get back to depreciation. Again, economic age-life method. It's a method of estimating, keyword, estimating depreciation in which the ratio between the effective age and the total economic life is applied to the current cost of the improvements to obtain this lump sum deduction. So the question, how do you describe this process in the report? In the summary of, and I'll give you a handout for this to show you where to get a hold of a handout. In the summary of sales comparison, I write, the adjustments for building characteristics are developed with the depreciated cost method. See page 3, adjustment calculations, and the depreciated cost adjustment summary attached. So here's page 3 at the bottom of page 3, right above the cost approach. I'll state adjustments for building cost categories such as GLA, bath count, basement size, and so on are based on the amount they contribute to value. in this case, the effective age is 12 years. It infers a depreciation of 20%. So the market is paying 80% of replacement cost for the buildings. So this must be a 60-year life house if 20% is 12, right? And then seeing the depreciation calculations attached, which includes the 80% factor applied to the relevant cost categories. And then I'll just put a screenshot of a page from the software that's all completed. So is it legit to estimate effective age? According to the Appraisal Real Estate 14th edition, and applying these concepts, it's called an estimate. So I think that estimate we make on page 1 can be used to develop depreciated cost adjustments depending on the scope of work. I like to support my effective age and not just estimate it. But if you're doing a desktop or a drive-by, which is kind of in the title of this webinar, is how do you use depreciated cost when you don't go inside the house? You haven't measured it. Well, you can estimate effective age. So depreciated cost analysis, it's depreciation, percentage of cost paid by the market, cost, marginal cost, and then the analysis part is applying the percentage of cost paid by the market to the marginal cost. Now I'm going to show you a software application. This is a desktop application that you install. You have to download it over the internet, but you install it on your computer, and then you do not need the internet to run this. It does require Excel to run. It's a compiled Excel file, so it can't be shared. But anyway, up here we start with the quality rating. That will pull the marginal cost into the calculations. The multiplier, that's something that you look up in the cost manual. This one's 3%. Economic life is 60. That's something that you can change. Anything in white is what you can change. Effective age is 20. So remaining life has to be 40. Depreciation is 33, and the market's paying 67%. And again, there's our example. This feature is used, you type in, again, anything in white is what you can change. You type in 2,000 square feet if you're appraising a 2,000 square foot house, and this just gives you brackets for looking for the right comps. Okay, it's just a convenience. Whoop. But what's happened here now is the cost of $90 for the Q4 has been increased 3% to bring it to this current market here. So 90 times 1.03, and then it's multiplied by 0.67 to give you this number right here, $62 per foot. Now, it's interesting. All these numbers here are labeled EQD. That means equal depreciation. This means 33% depreciation is applied to each of these categories. Okay, but now as an analyst, you know that, let's say, a fireplace, the first fireplace, yeah, that might be worth $2,300. The second fireplace, it might be only worth half as much due to a loss in I guess it'd be a functional depreciation item. The market doesn't expect 2 as much as they expect to have 1. Same with basements. The full bath, I always use 50 because now I've got a bathroom that's worth less in the basement because of a functional reason. Okay, so that's Sidekick. Again, it's an application you install on your computer, runs on Excel, so you need to have Excel. Our first application was this one, Solomon Adjustment. You can see it's kind of a lighter version. It doesn't have that ability to change the assumption about equal depreciation. But in this case, it automates the zip code. You type in the zip code, you type in, or you select the quality rating of 4. You select remaining economic life, and then you enter a factor. And this is due to things like multiple builds in a subdivision are going to cost less. There's help in the user manual that shows what factors arise from. Sometimes it could be, brick construction might be +6. But it gives you these adjustments, and then you can print the report or screenshot the report. But with an application like this, after 1 hour, all of this is going to go away. So you've got to keep a copy. On the prior one, this will stay until you change it, okay? So the Solomon Adjustment Calculator, it does adjustments, depreciated cost analysis, and this is the subscription. It does the cost approach. It's got all the data included in the subscription. It does new construction cost. And the reason that's important is because new construction has no depreciation. And this is a way to match the local builder's price or sale price to the cost manual to see what percentage of cost the builders are actually operating at in your market. Very handy tool. Site, it does site extraction because, you know, the site value is part of that calculation that we were talking about earlier. Guess I got to turn the phone off here. So market time, Solomon, this will also calculate market time adjustments based on your input of an appreciation rate. It'll also do manufactured housing, and it will do, you'll be able to find a PDF of a survey. It won't calculate it automatically for you, but you'll be able to look at PDFs of over 20 surveys that we've done for secondary data, like what is the value or what is the penalty for a busy road. Sidekick, it does depreciated cost analysis. It automates the survey adjustments. It does a market time calculation. Here's what Solomon looks like. And that's where you would go to subscribe, to log in, to read about what people think about it. Support, there's videos and so on here. And then here's how to get to Sidekick. But at this point, I want to stop sharing this. We've got about 15 minutes left. I just wanted to give you a quick look here. There's a lot of resources here under Great Links. You can use this to download recommended commentary. If you use Solomon, it'll be a Word document that you can use to copy and paste some of my comments. This one will take you off the site, but it's the lifespan of components to show you the difference in lifespan of things within the house. This one is a repair remodeling cost, good for cost to cure types of things. This is a very good website, except if you don't want to pay, you will get spam. They will send you all kinds of spam, but it's a good way to look and see how much it costs to do a roof on a certain house in a certain zip code. This is an interesting one, the cost study that shows the percentage cost breakdown for the National Association of Home Builders. I think it was a 2,776 square foot house about 3 years ago. This will show you how to decide if you want to use Solomon or Sidekick. And then this link will take you to Appraiser e-learning, where I've got a 7-hour CE class. I think they sell it for around $120. It's good in 21 states. But I just wanted to log in quickly, show you how that works. So I'm going to log in with my username and password. Here are the survey results. So for instance, you can look at this one and see that according to our survey, if you have 0 to 90 degrees above 80 degrees, 0 to 90 days above 80 degrees, and you have a Q4 house, a sample of 55 appraisers said it was a 1.3% adjustment, okay? So that's kind of what the surveys are like. We'll go to the calculators at this point. The last webinar, the internet went down right in the middle of this. Whoop. So here it is, enter a zip code. You can type in the word base to get to 0 percentage. So there's nothing to do with the zip code multiplier here. And if we click 4 and remaining life of 60, it means no depreciation. Here's that $90 again. If we do 30 years of remaining life, that's 50% depreciation. So that's all it's doing. It's just doing the math for you. You can print a report, either paper or save a PDF. But this one, again, is driven by your estimate of the effective age, remaining economic life. This one, Solomon Cost, you can just narrow this down. I'll just go through this very quickly. What we're doing is we're, instead of estimating effective age, we're going to estimate a market value. Whoop. And site value of 50, let's say. And site improvements, 10. We've got a survey for that actually. You can see what people are thinking. For zip code, I'm going to just say base. Oop, make this a generic house. It's a quality 4. It's got 1,500 square feet, central air, and there's all these details, but let's just say a 440 square foot garage. So now when I click calculate, it does the cost approach just that quick. So the base cost for a 1,500 square foot house, Q4, is $191.43, $127.62 per foot. You put that in the cost approach. $47.71 for the garage stall. That would go in the cost approach. I don't have any additional features here, but if I added a fireplace and click calculate, there's the cost of the fireplace, okay? Now this is a real key point. This depreciated cost of improvements, this $140,000, that comes from 200 minus 50 minus 10, right? So 200 minus 50 is 150, minus 10 is 140. That doesn't change no matter what the cost is, but that does drive the depreciation calculation. In this case, economic life is 60, and that comes from our selection of Q4. Effective age has to be 21 because depreciation is 35. And then down here, we can do our thinking. We can say a deck only has a 20-year life. That's 33% of 60. So those would be the adjustments I would take to the grid. And in the scientific method, here's the hypothesis. After our observation of the comps and the subject and so on, we think the house might be around 200. You put these numbers in the grid, that's your experiment or your test, and it comes back at 210. Now you've got a little bit different depreciation, a little bit different adjustments, and that's how I believe this is a credible way to get to market value. We're not appraising to a value, we're testing on a hypothesis of a value. We're getting the adjustments, we're putting it back into the system to see what that infers, and then put these back in the grid, and if we come up with 210, then we're done, okay? Now there's also a Solomon site, if you've ever done an appraisal where you need a site value and there's no land sales in the neighborhood. This is just backwards from what we just accomplished. So a $200,000 house in the base zip code, quality level of 4. Let's say this one was 1,500 square feet. It's got central air. It's got a fireplace. It's got a 600 square foot garage. Site improvements, we're going to estimate at 10. Whoop. An effective age of 18, let's say. That's the site value that's inferred by all of this information. Now, this is a good way to look at trade-offs. It doesn't give you answers. It gives you a way of structuring your thinking. Watch what happens when I change this to $5,000. There's an easy one. The site value has to go up to 40, right? Watch what happens when I change this just to 25 years. The site value shoots up to 65 because the house is worth less, it's got more depreciation, okay? So this is a way to one way to work toward a site value. We've also got a manufactured application if you do those. We've got a market time application that will apply let's say this is comp 1. It's sold for $250. There was $10,000 in concessions. This is a VA loan. It's sold today, or the effective date is today, and this thing sold way back here. And we know that the annual rate of appreciation was 3. It's the perfect comp. It's got a $4,800 time adjustment, okay? So that's how the Solomon subscription works. And now I'm going to stop sharing that. Okay, so now here we go with Solomon Sidekick. All right, so you can enter a quality rating here. Let's make this one a 5. And let's say that the multiplier is 0, it's base. And it's got an effective age of 60 years. no depreciation, or excuse me, all depreciation. All we got is the land. Let's say 30. So now we've got 50% depreciation. Here's our bracketing. Let's say it's a 1,500 square foot house. Yeah, 1,500. And there's the adjustments. And these are saved from before. So my calibration numbers are already here. So those are the adjustments I would use in the grid. Then I can also use the survey tool. Let's say the comp is worth $200,000. And I hit enter. A percentage adjustment is applied based on survey of the value of a third bedroom, a fourth bedroom, a busy road, backing to the freeway, a water tower, power lines, railroad tracks, a mild winter pool, a cold winter pool, and 1,000 square feet of pole building is worth $4,200. And a steel building with concrete floor, power, and so on is worth $1,400 or $14,000 per 1,000 square feet. Now, this is interesting. These survey numbers work better than I expected them to. What we're saying is that for, let's say it's a $220,000 house, the difference between a C3 and a C4 is $20,000. So it's an 8.9% adjustment, okay? The difference between a C3 and a C2 is smaller. Here's for quality. Condition is more important than quality. Until you get over here, now the quality is more important than the condition. So again, all these are based on survey results. It's a way to guide you. It's, whoops, it's secondary data, meaning that it doesn't come from the pool of comps that you're using in the report. But it is a way for you to look at the grid and you see an adjustment that needs to be made for one of these categories. And you're kind of pairing off adjusted sales and you think you know, but there's so many adjustments involved that you can't, it's really not a pure pair. Well, then just compare it to one of these. So now you've got two ways to look at that adjustment as you go through the grid and narrow the range of possibilities. This also has a time adjustment tool. It's a little bit more work, but it will show you, like in this case, if the appreciation rate was 2%, there's 381 days between those dates and so on, okay? So there's the depreciated cost analysis part of Sidekick. We have a 50% or a $50 coupon on Sidekick. If you go back to that original website, you can order that and type in the code BESAFE, B-E-S-A-F-E, to get $50 off. And notice that this calculator locks on January 1st, 2021. So this calculator is depreciating. We'll have a new one in December that has new cost data in it. But that was the best way I could figure out to do the system. So I'm going to stop sharing now, and now there's my face. And if there's any questions, Kyle, you could tell me, and I'll try to answer them without looking at my notes.
Yeah, so we have a handful of questions here.
Okay.
I'll go in order of asked. We have a question about regarding 7-hour class. Is it approved in Florida? How often are the surveys updated? How can you participate in the surveys?
Okay. Well, I'll start with the last question. The surveys are going to become a bigger part of this. We're actually breaking the surveys off into a separate entity. It's going to be called pureconsensus.com. It's not all figured out yet how it's actually going to work. I've got a website under development. We're just looking to find the right survey tool. And it's going to be really interesting because when you as an appraiser ask an agent if you can have an appointment to see their house for the appraisal, you have suddenly made friends with somebody. You're the most important person in their life for a couple of days. If you could send them a link to this tool and ask them to complete a survey, you could build a database with that of what agents think about the importance of a pool or a walkout basement, or it depends on what your market is, but that's the ultimate goal. So that's the survey piece. They haven't been done for a while, and we need to update those. the other parts of the question were, remind me, what was the second part?
Regarding 7-hour classes.
Oh, the 7-hour class? You would have to go to the Appraiser e-learning site. I don't believe it's approved in Florida. And the reason for that is Florida requires a certain type of final exam or something that isn't easily incorporated into the software that Appraiser e-learning uses. It is approved in 21 states, but that's still less than half. So sorry about that. I mean, you can take the course without credit, but you're going to hear me droning on and on and on about the same stuff as you just saw on this webinar. If you do need the credit and it's approved, I think it's approved in places like Ohio is a big one, Colorado, Virginia, I think it's South Carolina, North Carolina, but 21 states, and they're listed at Appraiser e-learning under the depreciated cost class. And then the first part of the question again, I didn't take a note here.
Oh, that was it.
Okay.
I think we got it.
Right.
And then next, what are the major differences between the online version and the Excel version?
Okay. First of all, the Excel version, you need Excel. You don't need to know how to use Excel, but you need Excel to run it. The biggest difference I find is that it saves my data forever until I change it. I just click on it to open it. There's no internet connection involved. There's no login. I don't have to remember a password or a username. And it's very fast for doing desktops. It's very fast for when the scope of work doesn't make you feel uncomfortable about doing, cost-related adjustments without seeing the house, without measuring the house. I use the web version whenever I'm doing an interior inspection for sure, because then I'm taking my sketch data, putting it into the system, and I think I've got a more complete analysis because I'm actually supporting my effective age by an estimate of value, and then I'm supporting my adjustments with the cost approach and then with the surveys. The $15 monthly fee for the web version, you can stop after the first month, so it's only $15 to try it. There's actually 2 weeks free at the beginning, so you can try it out for 2 weeks. Give me a call. I'll take you through it. I'll spend an hour with you on the phone to explain it to you one-on-one. And I guess the other differences are Solomon Sidekick is faster for some things, but it's not as complete. The actual web app, that's a pretty tricky piece of software that requires programming. I don't know how to do the programming. It's a long, expensive process, but I can make a spreadsheet and have it compiled and made into this app pretty efficiently.
Next question. We have a user using site value and getting negative numbers sometimes.
Okay.
Why would that happen?
Well, that's because computers tell you they can't think for you at all. So it's if the site value is negative, that means that the cost is too high. That might be best handled over the phone. We can share the screen and I can show you some solutions to that, but it has to do with the maybe the quality, maybe other assumptions, but obviously we can't have a negative site value. It's just a clue that either the cost data is inaccurate in your area, and I can show you a way to find the factor to use for your area, extract the percentage from the market to dial that in for you. But that's going to have to be some give and take over the phone, which I'm happy to do.
Next question. Are survey results automatically loaded into Sidekick, or how are those served?
Yes, the formulas in Sidekick, all they do is they take that percentage of the average. Like for instance, on the survey about a busy road, the most frequent answer might have been 5%. The middle value might have been 5.3%, and the mean was 5.7. I used 5.7 or 0.057 then to multiply it by that comp that you've entered. So yeah, it does it automatically. You don't have to look them up and do the math yourself.
If I purchase Sidekick, will I need to cancel my web subscription?
No, you can have them both. Of course, they're free for me, so I have them both. But Sidekick is just it's a convenient way to do part of what Solomon can do. It's faster for the parts that you need if you're just doing desktops or drive-bys. And I thought that was a good reason to start these webinars, because a lot of us are looking at doing desktops and exteriors at the current state. So I started working on that, long ago, before Fannie Mae backed off on the hybrids, but I thought that was going to be the product for hybrids. But so it's been sitting there for quite a while, but I think all of a sudden now it's got some more traction just because of the current state with the COVID crisis.
And then we have one last question here. I'll do my best to condense it. How close does the estimated market value need to be? I just appraised a house that I initially estimated at $275,000, but after adjustments realized it was closer to $260,000. How much would that affect the adjustment given?
Well, it doesn't affect the adjustments very much. I mean, if you change it to 265 or 260 in Solomon, the adjustment might go from $43 to 42, or from 40 to 40 to 38 or something. But if you're bracketing, the specific adjustment that you use is less important than the logic. Logic would include things like bracketing, and then knowing how to reconcile. Like the opinion of value is developed with most weight on Y because of X. To me, that's what we have to get to in the comments, is we have to say why we're giving one comp most value, or which comps are getting the most value. I mean, we're all used to doing the cost approach coming out higher than our opinion of market value, right? That's been going on for as long as there's been a 1004. So I would say don't worry about it. But if you really want to, get down to the details, run it again with that new value, run those new adjustments, and then you'll have an airtight, bulletproof appraisal if you ever get cross-examined.
And that's all we got for questions.